Good afternoon, my name is Andrew Gavin, and I'm here to talk to you about a tool I wrote about a year ago and I've been updating ever since. It's called OpenDLP, and how you can use that to steal sensitive data from thousands of systems in less than an hour. So just a standard disclaimer, I'm here just representing myself. Even though I work for Verizon Business, they have nothing to do with the tool, nothing to do with the presentation. And also, if you use my tool and you get in trouble, not my fault. So my outline here, I'm going to talk about what OpenDLP is for those of you who aren't familiar. This is, by the way, building on a presentation I gave at SMUCon earlier this year. My reasons for writing it, how the agent portion works. I'll show benchmarks between the agent and the agentless scanner, and you can see the drastic speed improvements that an agent offers. I'll give a live demo of the agent and also live demo of some new features. I've got 4 demos lined up. I plan on flying through these slides because I've got a lot. I don't have much time, but I do have quite a few slides, and I hate slides. I like demos. So, and then at the end we'll do I'll show my contact info, and we can have a few minutes for Q&A. So, what is OpenDLP? For those of you who don't know, it is a data discovery tool, and there are 2 components to it. There's a web app that kind of controls everything, and that's on the LAMP stack, so Apache, MySQL, and Perl. And then there's a Windows agent that runs on, obviously, Microsoft Windows. And it's open source, released under the GPL version 3, and it is useful for compliance people. So if you're like a PCI guy, you want to find out where your PCI data is, you would want to use this. It's also good for proactive network and system administrators because we all know they are proactive, right? And then finally, the coolest thing, what I do, I'm a pen tester, so I really wrote this for myself. And I use this after I get domain admin, and then I just let this thing rip on the entire network, and it's pretty cool. So, what was my reason for writing it? Well, there really was no free agent-based solution last year when I started this. And the only solutions were really GUIs that you could run on your desktop, like Cornell Spider, and you could hack those to be an agentless scanner where you would do a net use to the remote hard drive and mount it locally. But as you'll see with the benchmarks, it's not really ideal for a very, very large deployment. It's going to be very, very slow. So how does it work for the agent-based scans? How do you get it going? Well, the first thing you want to do is you want to create a policy, and this policy is going to be reusable. You're going to have your administrative credentials because the agent runs as a service, and you need to be an admin on the box to install a service. And then you can do other things like whitelist and blacklist files and directories. And then you want to configure your regular expressions that you're going to use. It uses PCREs. I assume we're all familiar with that here. And then a few other things that I'll show. Then you're going to start a scan, and you're going to, it's going to be deployed over SMB, and it's going to get kicked off by the WinExe program, which is like the Linux PSExec, and it can concurrently deploy the scanners up to as many as you want in parallel. So instead of just sending out one at a time, you can send out maybe 30 or 50 at a time just to get it going faster. Now, when the agent is running on the Windows boxes, it's going to run as a service, as I said, but it'll run at low priority, so no one's really going to see or feel it. There's not going to be a little pop-up GUI box or nothing in the system icon tray or anything like that. It's also going to limit itself to a % of memory. So if you want to scan some huge 10 gig file and the Windows box only has a gig, and you try to load that 10 gig file into 1 gig of memory, bad idea. So what it'll do is it'll chop up that large file into smaller chunks that's defined as a % of system memory, so like 10% of system memory or 20% or whatever you decide to use. Finally, when it's done, well, it's going to scan, it's going to go through the whitelist and blacklist and then scan the resulting files. And then every so often it's going to ping back to your web app with results, and it'll give little status updates and stuff. And this is done securely. It's over a 2-way trusted SSL connection, so if someone tries to man in the middle it, it's not going to do anything. It's written in pure C. There's no .NET requirements, so if you want to run this on an old Windows 2000 or XP box that doesn't come by default with .NET, it's still going to work. And finally, when it's all done, it's going to uninstall itself automatically as a service. It's going to delete its directory completely. Really, the only way that you'd notice it was there is by looking at the logs, and certainly 99% of the Windows users won't even notice it was there in the first place. In the web app, you can monitor the agents, and as I said before, it's going to ping with results every so often, and you can see how many files and bytes it's processed. You can control the agents, pause, stop, uninstall, resume the agents, and you can also view the results live as they're coming in. You can, if you see a finding, you can download that file just to verify if it's actually there. there'll be a little hyperlink there, and it'll tell you the byte offset inside the file where it thinks it found whatever regular expression. Like I found a SOCH number at offset 500 in this file. So I know what you're thinking. Yeah, I invented multiplayer grep, but someone, I guess, had to do it. Just to go through some benchmarks, these are the specs. It's a couple of years old machine, but just for the sake of this benchmark, I ran it on 2 gigs with 13 regexes. It took just over an hour and 7 minutes. I'm not going to go through the rest of this, but on the flip side, an agentless scanner, the same exact thing took an hour and 20 minutes for 13 regexes. And for the agentless scanner, of that time, about 20% of the time was spent downloading the files, because with an agentless scanner, you basically have to download the entire file system to your own box so you can process those files. So 20% of the time was spent on that, and nearly 80% of it was spent on crunching the numbers. Now, if you're going to do this for more than one box, more than one target, you're going to run into some bottlenecks, and probably the biggest bottleneck is going to be your own system's CPU, and that's what's really going to slow things down. So just for one system, it's only really 19% slower, but if we extrapolate this to more systems, we see here the blue line is the OpenDLP agent remains flat, just about 1 hour. And the agentless scanner with 1 core for 25 systems will take over a day. Just 25 systems takes over a day. Oh, sorry. So on the bottom, there's really not much information. It just says, for this graph, it shows from going from 100 to 2,000. Sorry about that. So for 2,000 systems, which is way on the right, it'll take almost 3 months to scan 2,000 systems with a single core system that I use my benchmark on. But with the OpenDLP agent, it just takes 1 hour, and you can't see that, but trust me, it's there. So it just remains flat. The upsides to an agent-based solution are that all the computations are done on those victim systems. It's basically a distributed project. It's like CD, but instead of searching for aliens, you're owning data. And it also doesn't have much network traffic. It's only sending out about 1 meg initially with the agent, and then every so often it pings back with those results and the log files. So it's really not a whole lot of traffic. The downsides to the agentless scanner are, of course, everything has to be processed by you, by your own laptop or your own system. So if you're going to do this 2,000 times in parallel, it's really going to crush your CPU. And of course, you have to download everything to your system as well. So I'm going to show a live demo of the agent. And this is the interface. Let me make it a little bit bigger. And what you first want to do is you want to go to the profiles, and you want to create a new profile. So for this, we'll just call it agent. And we'll select the Windows file system for the agent. And you can mask or unmask sensitive data. I don't like to mask sensitive data because that's lame. So we want to do the local administrator account with the secure password of blah123. You have to specify the domain or the work group. If you don't have the password, though, if someone sent a patch to me, you can put in the SMB hash. So even if they've got like a 64-character long NTLM password that's super complex that Rainbow Tables won't even touch, no problem. Just put in the SMB hash and you're good to go. The install path, this is kind of important because when the agent is uninstalled, it'll recursively and forcefully delete this directory. So please do not install it to the Windows directory or anything like that. You've been warned. This is the memory limit that you can set where it'll chop up the files. Here's where you can whitelist and blacklist directories. So I've got some sample data in this directory. And likewise, here's where you can whitelist and blacklist file extensions, so pictures, movies, EXEs, things that you really probably don't care about that would contain sensitive info. Here are the regexes, so we'll check some of these. You can add your own regexes. As I said, they're based on PCREs. These options here tell the agent what regexes to treat as credit cards. So if it thinks it ran across a 16-digit number, you might think it's a Visa or MasterCard, but it's going to run that through the mod 10 check. Yeah. Yeah, exactly. That's what this is exactly. So it'll cut down on false positives. And these options here, it'll read inside zip files. So Office 2007, OpenOffice, just normal zip files. It'll pass them over once as a normal file. Then it'll try to unzip them and go through its contents a second time. This is the upload URL, and the takes basic authentication credentials in addition to the certs. So I don't want to fat finger it, so I'll copy paste. This is the time between uploads, so how often it'll ping back. And we just fill out this stuff and submit the new policy. Now we want to go to start the actual scan. So we'll just name this agent. We select the profile that we just created, and we enter our guinea pig here, and it's going to start. So if you were to scan maybe 1,000, 2,000 systems, on this screen you would see a live scroll of this here saying 0 systems remain, or 500 systems remain in queue, 400, 300. Once you get down to 0, then you know it's safe to leave this page, because if you leave this page before, then it might interrupt the deployments. So if we go back now to our guinea pig system, we can see that OpenDLP is running below normal. It's going to run as a service, and let me try to bring that up. Oh, it's just done. But we see here it's running as a service, and eventually now it's gone. So when it's done, or even while it's running, you can view the results live. So you just go to the view scans and results, and this is it's going to give you a summary of the scans here, and you select one, and here it's going to give you all the systems in that one scan that I just launched. So there's only one system, and we can view the results here. So we found possibly a SOCH number, let's say in this file here, so we can click it, and we can download it and open it. And we see, yeah, there's probably a SOCH number, the number 1s, number 2s, and then down here, number 3s, so we can verify that. If you think you found some false positives, you can check these guys and scroll to the bottom and just mark them as false positives. Go back, they're gone. And if you think you accidentally marked something as a false positive, you can manage your false positives here and just drill down to the system and uncheck a couple. Now they're not a false positive. We can go back to the results and refresh, and they're back now. So that's pretty much it for the agent scanner. Let me go back to my slides now. Recently I added some new features though. I gave a talk in Amsterdam in May, and I added database agentless scans. So I've got support for Microsoft SQL Server and MySQL, and then most recently, right before this conference, I added agentless support for Windows and Unix. So for the database scans, it's very, very similar to creating a policy for an agent scan. The only difference though is that instead of whitelisting and blacklisting files and directories, you can whitelist and blacklist tables, databases, and columns. That's pretty much the only difference. It's going to run as a shell script, a Perl script, on your own system in the background, and it's going to walk the database structure just like you would walk through a SQL injection. So it's going to enumerate the databases and the tables and the columns, and then it's going to go after the data. And then you can control the scans too. So I'll give a quick demo of that. So we're going to create a new profile again. We'll call this MySQL. And test and test. And here's where you can whitelist and blacklist your databases, your tables, your columns. You can limit how many rows you can grab. So if you want to grab all rows, just enter a 0. But if you're going to just be aware that some tables are quite large. If there's a million rows, it would take a while. So we'll submit that, and we will launch our scan just like we did last time. Select the profile that we just created. I'm going to cheat and just do loopback because I didn't bother to set up MySQL listening on 3306. So this is going to go pretty fast. In fact, it should be done because there's not a lot of stuff. Here is the scan that we just ran, and we see that it's done. And we see, well, you guys really can't see that. There's 5 findings, trust me. And they're all SOCH numbers, and it'll give the database, the table, and the column name. So if we want to verify that, there's no option for me to verify that right now, but what we can do is just go into the database itself. And we see that here's what it found, all that good stuff. So that's it for the MySQL demo. Now what I'm going to do is demo the agentless OS scan. Let me talk about it first. The policy is again very similar. You don't need admin credentials for this scan. It's helpful, but obviously if you don't give it an admin account, it's not going to be able to read all the files most likely. So it's also honors the whitelisting and blacklisting, the memory sealing. It's going to be the memory sealing on your own box, not on the guinea pigs. But and then it's going to run in the background as a shell script, as a Perl script. And I currently have support for Windows, the entire file system over SMB, Windows shares. You guys can't see that. And then also Unix over SSH using the SSHFS method there. So I'm going to do a demo of Unix real quick. So I'll create a new profile, call it Unix. And I've got some test data in a directory somewhere. So I've only got about 5 minutes left. I don't want to scan my entire system. And again, the same file extensions options, the regex is here. Credit cards, zips, and we're good to go. We'll start the scan. And it's now started, so we can view it as it's going. And wow, it's okay, it's already done. And it's just like the last time. You can see the results and do all that good stuff. So, and then finally what I'm going to do is I'm going to demo a Windows share, because that's just slightly different. So we'll create a new profile. This one, this particular share is completely wide open. You don't need credentials at all, so I'm not going to fill in anything. So when you run your vulnerability scanners, you'll probably see that quite often. The directory here, though, is a little bit different. It's relative to the path of the share that you're going to give it when you start the scan. Because if you try to put in, C:\Windows, it's not going to know where that is, because it's got to be relative to the actual share. So we'll just leave that blank for now, and the file extensions and regexes again. And the same thing, credit cards and zip files. So we'll submit that, and we'll start a new scan again. And there's a slightly different thing here where instead of giving it a list of IP addresses, you have to give it the actual full path to the share, so it knows where to go. And if you were to whitelist or blacklist file or directories, it would just append them here like that. But you don't have to do that. Just give it to the base path of the share. So we click Start. And it's going to go in the background. It's going to download all those files over the share, and we can view the results as they're coming in. And wow, it's faster. Usually, if you catch it in time, you're going to see that it'll give you like I'm 20% done. I'm estimating there's maybe a half an hour left in my scan, but just for the purpose of this demo, I don't have that much time. But here again, you can see same exact stuff. You can download the files, check them out, and you're good to go. So conclusion for pen testers, OpenDLP, it's free, it's open source. After you get domain admin or after you find some database credentials or Unix credentials, let it rip, because you can show the C-level executives, show your customers that there's very much risk to getting domain admin. A lot of those people don't really realize that, oh, you got domain admin, okay, whatever. But if you show them that, oh, okay, well, here's all your customers' SOCH numbers, or here's all your customers' credit card numbers that were on Peggy in HR's system, or Bob in finance's system, that it's pretty damning. And then finally, for everybody else, if you're some sort of admin, this is free, and really you should be using this to find your own sensitive data on those weird systems that you don't know about before people like Anonymous or LulzSec or our favorite nationally sanctioned hacking groups use or find. And just to reiterate, it's multi-platform. It does file systems and databases, so really there's no excuse why you shouldn't be using this. But this is the project page. It's on Google Code, and the current version is 0.4, and it's kind of a bit of a pain in the ass to install, so I made a VM about a year ago. The VM is a little outdated. I'm going to update it in the next few weeks, but it's based on 0.2.2. It's easy to upgrade. And then my contact info is there. And I believe we have time. Yeah, we have maybe 5 minutes for questions if anybody wants to. Yeah, go ahead.
Have you looked at using iPhone
Sorry.
Have you looked into using iFilters on Windows to look at binary file types?
The question is if I've looked into using iFilters on Windows to look into different binary types. I do want to get into that, especially Outlook PST files, because those are just going to be a freaking goldmine. Yeah.
For countries that don't have Social Security, national ID, some other, can you customize that?
Yeah, in fact, you can make your own regexes. So just by default, it comes with 13, but here's an interface here where you can create your own regexes. So just give it a name and, you know, some kind of pattern here or whatever, and then just, you're good to go. Yeah.
How do you handle actually examining the files? Because definitely for management, it's going to be worried about it. It's altering the database of files. How do you handle open files? What's the actual process so we can guarantee to them that this is relatively safe? It's not going to modify data. Because when you show something like this, especially since it's open source, they're kind of tentative necessarily to run it. I'm saying this because I tried running your tool, and that's the first thing they came to me.
Okay.
They're like, well, how do you know this isn't going to, you know, and I'm like, well, I mean, actually show them the source code, but that's not really going to, so how do you?
So the question was, how do I know that this tool won't modify data or harm data in any way? Because people are leery about open source tools. I open the files read-only, so if they are modified after I open them, I am not sure what happens. But it will not purposely modify the files at all. It's just read-only, strictly read-only.
And what happens if there's any errors? We get like, I couldn't read this file.
Yes, it would be listed in the logs here. There's a section here for the logs, and any file that I cannot open, it's going to be mentioned here in the logs. So there's not much here. I can open all the files that I could that I tested on my demo, but it will mention it there. Yeah. Have I thought about enumerating cackles? Oh, the ACLs. Okay. Not so much right now, but perhaps down the line. Yeah. Yeah. Great question. So, as a consultant, I don't like to leave my systems on the job. And his question was, how do agents deal with a lack of communication with the web app or your own server? And there's that phone home option every 5 minutes or whatever you set. It's going to keep trying every 5 minutes. If it cannot contact your web app, it's going to keep running and it's going to keep doing its grep. And then every 5 minutes, it's going to try to phone home. At the end, if it's completely done searching all the files, it'll try every 5 minutes just to phone home still. So let's say you launch the scan on Tuesday, you come back in Wednesday morning and plug in, you're just going to get a crap load of data like in the first 5 minutes. It's kind of cool to watch. But yeah, it'll handle miscommunicating with the web server just fine. Yeah. It depends on how many systems you're running and also how many findings there are, and certainly you can set the log verbosity in the profile too. I haven't really investigated it too much, except that I know it can handle several thousand just fine on just a decently recently made laptop. No, there are no agents on a database server. The database scan is agentless, so it's going to remotely connect and download all the tables and stuff. Yeah.
The question was, how much impact does it have on the database server?
Negligible. It's just downloading the tables and stuff, just like a normal client would. It downloads it locally and then does the processing locally. It doesn't do anything on the database except to download the data. Yeah.
Have you thought about adding like a self-destruct so that you can set it so that if, say, it can't get in touch with the server after 3 days, it removes itself?
So, yeah, the question was self-destruct, like if it can't contact the server after a few days, it'll just uninstall itself. The problem that I ran into with that, I haven't thought of that, but I'm thinking of how Windows works, and you can't, as from what I understand, a running process can't uninstall itself because it's running. I might be wrong, but that's why when these uninstall them, when OpenDLP uninstalls itself, it's the web app sending another one of those WinExe commands to the system. But that is a really good idea, just to cover your tracks more. Yeah. Another great question. What happens when the victim systems that you're scanning with the agent die or they get rebooted or something? Since it runs as a service and it'll automatically restart when the system restarts, and OpenDLP knows it keeps track of the last file it scanned, so it'll just go back and resume where it was before. I mean, if the system is completely dead, obviously nothing's going to run on it, so I can't help that. But if it gets rebooted or if no one's logged in, it'll run and it'll resume just fine. Antivirus, good question. Right now, OpenDLP is not labeled a virus by anybody, and I think if it ever does, it'd be quite interesting because a lot of those AV companies also have DLP programs, so little conflict of interest there, but right now it's not identified as a virus. If it tries to open a file that's identified as a virus, then something will pop up and the user will see that, because I've run into that with AVG on occasion. Yeah. Like a schedule? His question was, have I set up any sort of scheduling or do these systems at a particular time? Not yet, but that is on my to-do list. Absolutely. Anybody else? Otherwise, I'm going to wrap up. Yeah, one more question. I'm sorry, it's really hard to hear you. How am I what? Oh, how am I storing the data? It's stored locally in a MySQL database, and you can select whether to mask or unmask that data. So if you select to mask it and you're worried about you becoming another risk, it'll mask the first 75% of whatever string it finds, and it'll leave the last 25% unmasked. But it is stored in plain text. If you are really worried about it, you can set up a TrueCrypt volume for your MySQL stuff, but that's kind of outside the scope of my tool right now. But that's all the time I have. Thank you.